Now let us talk about cluster topology. At this time, we'll be getting overview about a production cluster. A detailed module will be there at a later point in time, where we'll be discussing about capacity planning with respect to production cluster. On top of very high level overview about production cluster, we will also see how we are going to explore the process of building clusters using 8 nodes. A typical production cluster will contain hundreds of nodes, out of which few servers will contain databases to store data for different services. Typically, you need to work with the DBS who own the databases, and you have to ask them to provide you the database for different services such as high Woozy, Cloudera management service, or if you are using Hotbox distribution, there should be a MySQL or Postgres or Oracle database for Hotbox management service as well. So you need to discuss with the DBA team, get the approval with respect to change management, and you have to get the databases from them. Typically, big data administrators will not be worried with respect to the databases which require to run our services. However, in some cases, especially for POCs or even in regular production clusters, big data administrators might have control on creating these databases as well. You just have to build the required skills to set up databases if it is required. It is pretty straightforward to use databases like MySQL, Postgres, etc. However, if it is Oracle, typically you will not be allowed because Oracle comes at a very high licensing cost, and it is typically driven by a dedicated team within the enterprise, unless you are working with for a very small company. That being said, few servers which will contain databases to store data for different services. Big data administrators might or might not manage. Most likely, they will not be managing these database servers. And then we need to have 1 or 2 servers to run management tools based on distribution. If you are using Cloudera, you have to set up Cloudera Manager and Cloudera Management Service. If you are using Hotworks, you have to set up Ambari or as well as Ambari Metrics. If it is Mapper, the component names might be different, but there will be certain tools to manage the cluster. You need to have 1 or 2 servers to run management tools. Then, when it comes to production cluster, your clusters are typically categorized into 3. One is gateways, second one is masters, third one is workers. Here, I have logged into our big data developer labs, which we provide to learners, especially developers, to learn big data tools for development purpose, such as Spark, MapReduce, etc. And we have a 11 node cluster. And you can see that the naming convention vary for different nodes. You have WN for the majority of nodes, and then GW for few nodes, and then mixed naming notation for others. So GW stands for gateway, WN stands for worker nodes or slaves, and the others are categorized as masters. So gateways are typically used to deploy the applications where the applications will be connecting to the cluster and store the data or process the data on the cluster. When we say cluster, it is about connecting to these masters or workers wherever it is appropriate, and then either store the data or read the data or process the data if it is a Spark or MapReduce based job. So gateways are the ones which will be used by the operations team to schedule the jobs and developers to troubleshoot the issues. Only big data administrators will have access to the other nodes than gateway nodes. If developers or the operations team have to connect to the other nodes than gateway nodes, we have to set up proper policies where they have to submit a request and get the temporary access to troubleshoot the issues. Okay, so you will be having 2 or 3 gateways, and then there will be handful of master nodes to run master process. Typically, on a larger cluster, we will not share the nodes to deploy master components of different services. For example, Zookeeper need to have 3 servers to run its components on a cluster. HDFS require at least 2, one for name node and secondary name node, or active and passive name node, depending upon the type of configuration we are using for HDFS name node. And then 2 servers required to run resource manager, 1 server for Hive, 1 or 2 servers for Impala, 3 servers for HBase and more. So on a larger cluster, you might want to separate these components onto different nodes. If that is the case, you need to have 3 plus 2, 5, 7, 8, 10, approximately 12 to 13 nodes to run all these components, master components of different services on different nodes. However, on a smaller cluster, or if your server size is big, which means it has a lot of memory and CPUs, then we might consolidate these into fewer nodes. Okay, so the number of masters might vary between 4 to 12 nodes in a typical production cluster, depending upon the size of the cluster, which means number of nodes in the clusters, and also the size of each of the node on which masters are being set up. Okay. That being said, rest of the nodes are categorized as worker nodes, where we deploy slaves associated with all the services. The slaves are data nodes for HDFS, node managers for Yarn, region servers for HBase. If you are using Cloudera distribution and if you set up Impala, Impala D for Impala, so on and so forth. So here, the slaves or worker nodes are nothing but these things. And if you click on this, it has service components such as data node for HDFS service, a region server for HBase service, and then node manager for Yarn service. Whereas if you go to the master, you don't find data node or node manager on this. You find HBase master, name node, and then zookeeper. Similarly, if you go to resource manager, you will find again HBase master is set up on all the 3 masters because it requires three different servers to set up HBase, and also you will find zookeeper on this. On top of these things, you also have resource manager. Okay, so typically we mix and match on fewer servers with respect to master components of different services. That being said, at a very higher level, this is how it will look like. Databases that are required to store data for your Hive Metastore or even for your management services are typically managed by DVS. That's why I did not include on this except for this monitoring database. Then you have fewer clients, typically 2 or 3 clients for fault tolerance or load balancing of your applications which are being deployed on these clients. It will have monitoring agent, and then client for HDFS, client for Yarn, client for Spark, so on and so forth. And then you will have handful of masters, where the components of master components of services such as name node for HDFS, secondary name node for HDFS, resource manager for Yarn, zookeeper, etc. will be deployed. And then you will have tens to hundreds of slaves where you will be having monitoring agent, and then you will be having slave component of the services such as data node for HDFS, node manager for Yarn, etc. All the nodes that are part of the cluster should have monitoring agent, depending upon the distribution you are using. If it is Cloudera, you need to have Cloudera manager agent. If it is Hotworks, you have to use Ambari agent. And these actually send details to the management server, which is this one, and it will actually put the data into the monitoring database, and it will serve you reports so that you can actually watch the health of the cluster. You can also configure alerts to send notifications if there are any anomalies on your cluster. Now, when it comes to learning, you don't need to have very large cluster. You can start with 8 servers and get the ball rolling to understand the step-by-step process to set up the cluster by understanding architecture of each of the component. So we'll be using 8 servers to control the costs. Out of these 8 servers, we'll be using 1 server for gateway, and it will also contain management services based on distribution. So we will be having MySQL server with multiple databases, because we need to use a traditional RDBMS for different reasons, which I will be explaining later. On the same gateway, we'll be having, depending upon the distribution, management service components as well. If it is Cloudera distribution, we'll be having Cloudera Manager and Cloudera Management service components. If it is Hortonworks, we'll be having Ambari and Ambari Metrics on this gateway. So on one server, we'll be having multiple things because we have limited capacity. And then there will be 3 masters, and we will be sharing these 3 servers to deploy all the master components of different services. For example, if you want to set up HDFS, out of these 3 masters, we will be using 2 of them, and we will be setting up name node and secondary name node, or active and passive name node, depending upon the type of HDFS name node configuration. Again, out of these 3 nodes, we will be using 2 nodes for resource manager and associated history servers. All the 3 nodes will be used to set up Zookeeper. All the 3 nodes will be used to set up HBase master and more. So we'll try to use the 3 masters to deploy master components of all the relevant services wherever masters are there. In some services, such as Scoop, we don't need to deploy any masters. In that case, we don't need to worry too much about setting up anything on these 3 masters. Then we'll start with 3 workers, where we'll be setting up HDFS, yarn, HBase, etc. And we will add one node at a later point in time, so that we understand how to add nodes to the existing cluster as well. So using 8 nodes, this is how we'll be learning. Once this is done, we'll actually get into the detailed module where capacity planning is done for a much larger cluster, leveraging the skills which are gained while setting up this 8 node cluster. That being said, by the end of this session, you should have a GCP account if you want to use Google Cloud to leverage $300 credit. You should have created instance template. You should have provisioned 8 servers. Probably you might have stopped by now. That is fine. You also need to have set up Ansible. You also need to have Ansible on first server, and then you have to format and mount additional storage. Also, it will be better to set up mobile app to monitor the usage of your credits as well as to manage servers. So Google Cloud will provide you a mobile app on Android or iOS. You can actually set up that app. That will facilitate you to stop wherever you are. If you forget to stop after going through this session, and if you want to confirm whether it is stopped or not, if it is not stopped, if you want to stop, having this mobile app will help you significantly. So make sure you have the mobile app also before you proceed further.